Hello and good morning, guys. So we are here to discuss on market basket analysis using appropriate Apriori algorithm. As we install some of the packages, we need NumPy, pandas, and we have MLxtend frequent patterns. We are importing Apriori algorithm and association rules from it. Now we had the groceries dataset.csv. In groceries dataset.csv, we have three rows, which is namely member number, date, item description. As you can see, this is the data. I have gathered this data. I have collected this and downloaded this data from Kaggle dataset. And it is a transaction type of data which contains date, the time, and the year, and the item bought. Okay. So why are we doing this? We are doing this for suggesting better products at a suggestion to customer, thereby increasing the business revenue. As if we go to a shopping mall or say let's say online site, we get a recommendation of products that are frequently bought together, which means the business perspective, which means from the business perspective, we can increase our sales by clubbing or giving some kind of offers, or let's say recommending the product to the end customer so that he or she may or may not buy it. Okay. Now, how to make that decision? This decision is made using the transactional data, which is here. This contains item description, and these are various types of items that are frequently bought in a store. Let's say. So, here comes the data preparation part. What we are doing is what we are doing is using the MLxtend library, which contains a priori algorithm. This a priori algorithm works and extract the frequent item sets for association rule mining. Now, the what are frequent item sets? Frequent item sets are these which meet the user specified support threshold. Now, what does support threshold mean? Support threshold we are setting it as 50%, let's say. So frequent item sets are defined as a set of items that occur together in at least 50% of the transaction. Okay, means if we are buying, let's say, whole milk, whole milk occurs in 50% of the transaction. That is the reason we are using frequent data sets. Okay, and then what are association rules? Association rules are the generation. These are generated using the frequent item sets. These are simply expression of x implies y, which means if you are buying x, then if a function is x, then it implies to y. Okay. Example: if a person is buying diaper, let's say, and he is also likely to buy beer. Right? And this is a hypothetical case, let's say. So this shows an interest in purchase. This has two metrics which are lift and confidence, which will be discussed next. Now, we are here on data preparation. So what we are doing is in the item description column, we are removing any white spaces or blank spaces from the front side or back side of the text, which will give a cleaner text. Now, in the axis zero, which means our this one, our row numbers, we are the subsetting or subset number. Also, we are using the function of drop NF, which means on my retail data, it will drop the items which will drop the rows which have empty spaces, which means an n, and in place, which means we are not updating our data frame. We are just modifying it. Okay, and then my retail data, the member number. This means this one. This let's say invoice numbers. So we are converting into string type. Okay, this whole column is converted into string type data sets. And if we display it, it will go as like this: head.10. Then if we count the values, we have the whole milk of 2,502 counts. Other vegetables are 1,898 counts, which means this is a pretty big data. Okay, and the data type is integer 64. So, dot value counts. We have the shape of data is 38,765 columns. No, columns not. 38,765 rows and 3 columns. Now, for API algorithm to be used, we have to group the data, and by grouping the data, we mean that the member number and the item description have to follow certain rules. We are applying the count, unstack, reset index, and set index. Now, what is this? This will be a technical term, so I'm not explaining it, but I'll write it in the README file. Now we got this data as a 0.000.00, which means that for a specific member number, let's say 1001, and we are not getting the full data here. If we export the CSV file, we will get the full data. But if we say, suppose let's say I have member number 1001. If the instant food products is bought, it will show as 1. USD milk is bought, it will show as 1. So here it is not bought. So, okay, the beef is bought. Okay, so here shows 1.0. This is a group description of whole of the products bought. Now we are converting this data. Why are we doing this 0.00 and 1.0? Because the a priori algorithm expects the data to be of the form 0 and 1 only. That is the reason why. And here is simple logic that returns the if there are 0.00, which means if it's greater than 0, then if it's less than 0 or 0, then return 0. And if x value is greater than 1, then return 1. Okay. And then we are mapping at my encode units, and have our final data as this. This is a clean data set ready to be applied to rules of and get the training model. Now, in the training model, we are using the my frequent data sets, which we made here. My frequent data sets, which will make a priori algorithms. My basket sets, which we made here. My basket sets by mapping the encode units. Minimum support threshold, which is 0.07. Now, suppose as already told, we are expecting and getting the threshold support to be 0.07, which means 70% of support. And using the column names too, you are using column names. And then the rule are generated as association rules we are applying on my frequent item sets, which we generated here. We are using the matrix as lift 10. The minimum threshold is 1. So by applying the association rules, we get these many tables, these many columns and rows. Here is antecedent, here is consequent, antecedent support, consequent support, support left register, support left confidence, representativity. These are the terms which we do not need now, but these are advanced terms. So here we are focusing on support, confidence, and lift. What are antecedents? Antecedents are products that are, let's say, we said earlier that X implies Y. So the X represents antecedents and the Y is consequent. Whole milk and bottled milk, if suppose, let's say, a person buys whole milk and he is also buying water milk, buying bottled milk, bottled beer, the probability or the support for it is 0.085%, which means 8% chance is there to buy the whole milk and bottle milk together, which means 8% chance is there to buy bottle milk, bottle beer after buying whole milk. Okay, so these are the table which we get. Now it's just simple. So this data was little skewed. The whole milk was the most bought item here. Okay, so what we did is we found out the maximum value of confidence. It is 0.597 and the maximum value of lift, which is 1.32. So we thought of a rule of why not use the maximum values and get the maximum possible result and the strongest recommendation possible. So we used the rule as if lift is greater than 1.2 accepted and the confidence is greater than 0.5 accepted. So this is an AND condition and we get the final result as the if a person buys other vegetables, rolls and bun, he is likely to buy whole milk. That is, we can recommend whole milk to be bought with other vegetables, rolls and buns, and also yogurt or other vegetables. Also, we can suggest the customer to buy whole milk. That's it, and that is it for today. And this was market basket analysis. So this can be used. Market basket analysis is a proper technique, and this was a very short example, but here we can also implement recommendation models. Big techniques can be used here. So its applications are in retail and e-commerce. You can recommending product bundles as we see in let's say Amazon or Flipkart or wherever we visit online. So we see if a person buys mobile, the recommendation is for charger or phone cover or let's say case cover or insurance policy, etc. Marketing strategies. Um, many marketing companies Many marketing companies also offer combination offers, or let's say for if we are buying a helmet, then we get complimentary gloves, etc. That is a strategy they're using, and the competitive pricing also. Supply chain optimization, we are using the stock products buying on based on buying patterns. So that is it for today, and hope you like it. Thank you.